This video is a presentation for Sudoku solver and checker. The project objective is first one. Build a Sudoku solver and checker use recursive. 2. Build a Sudoku reader to read Sudoku puzzle in the .csv file. 3. Add the graphic user interface to the Sudoku solver and checker to allow the user solve and check the internal Sudoku puzzle or the customized Sudoku puzzle. Definition of terms. What is the Sudoku puzzle? The Sudoku puzzle look like this. There's a 9 by 9 grid. The goal of Sudoku is to fill in a 9 by 9 grid with digits so that each column, row, and 3 by 3 section contain the number to between 1 to 9. At the beginning of the game, the 9 by 9 grid will have some of the squares filled in. Your job is to use the logic to fill in the missing digit and complete the grid. Don't forget, a move is incorrect if any row contains more than one of the same number from 1 to 9. Any column contains more than one of the same number from 1 to 9. Any 3 by 3 grid contains more than one of the same number from 1 to 9. The Sudoku puzzle is not really complex. It's only 3 rules of it. So what is the recursion? The process is in which a function calls itself directly or indirectly is called recursion, and the corresponding function is called a recursive function. The properties of recursion is 1. Performing the same operation multiple times with different inputs. 2. In every step, we try smaller input to make the problem smaller. 3. A base condition is needed to stop the recursion, otherwise infinity loop will occur. And then I will talk about the backtracking. The main algorithm of the Sudoku solver is use the backtracking. A backtracking algorithm works by recursively exploring all possible solutions to a problem. The following is a general outline of how backtracking algorithm works. 1. Choose an initial solution. 2. Explore all possible extensions of the current solution. 3. If an extension leads to a solution, return that solution. 4. If an solution does not lead to a solution, backtrack to the previous solution and try a different extension. 5. Repeat the step 2 to 4 until all possible solutions have been explored. So actually, recursion and backtracking is very similar but not the same. Recursion do not always need backtracking, but backtracking always use recursion to solve a problem. A recursive function solves a particular problem by calling a copy of itself and solving smaller subproblems of the original problem. And then the backtracking at every step remove those choices which cannot give us the solution and continue to find those choices which have the potential of taking us to the solution. 3. Recursion is part of backtracking itself, and it is simple to write, but backtracking is comparatively complex to implement. The recursion application of recursion are tree and graph traversal, towers of Hanoi, divide and conquer algorithms, merge sort, quick sort, and binary search. The application of backtracking is n-queen problem. Rate in maze problem, ninth tool problem, Sudoku solver, and graph coloring problem. Interesting. Teams member, a mouse and a cat. Now here's the architecture picture. There's the my project overview. There's a Sudoku graphic user interface, a checker, a Sudoku puzzle itself, a reader, a solver, and the main application to run to show the graphic user interface. Here is the backtracking algorithm visualized. You can check this video in the other episode of my post. Here's the code example. Here, for this one is part of the Sudoku checker. So this function is check if the digit is unique in row. It's very simple to read. There's there's no special. There's only use the for loop to check to compare the input number is duplicate or not. Here's the unique in column function. The same idea with the previous one, and is unique in grid. Then the one difficult point is to find which grid is this position belong to. For using this algorithm, you can find the current location belong to which 3x3 grid and check the number of this grid to check if it is unique or not. Here is valid number. To use the previous 3 function to check if this number is unique or not. From here also belong to the Sudoku checker class to check if the input Sudoku puzzle is an eligible format or not. So there is an 9x9 is a 9x9 grid using the two-dimensional array list. Each dimensional the size is 9. Here I define a constant variable as the global variable here, the size. Then if the board if the input digit is less than 0 or larger than 9, or if that digit is not 0, and then check if it is unique in the row, column, and the grid. The next one is to check if that if that uh, Sudoku puzzle is a solution or not. Very similar with the previous function, but a little different. There's no zero input here to check if that digit is if less than 1 or larger than 9, and this is not unique, and then it will return false. This one is belong to the Sudoku solver class. It's get the free cell list. That is get all the empty cell from the Sudoku puzzle, and I use the 0 replaced by the empty cell. The 0 is the 0 means that this position is empty. The next one is search. Put the two-dimensional array list. Put the two-dimensional array into the search function, and then get the free cell list, and then search. This is another search function. This function is search a solution starting from the k free cell in the free cell list, and then if the k is smaller than the size of the free cell list, then retrieve the location of the free cell list. Then try to insert a number from 1 to 9, insert it, and then backtracking to get the answer. On here, if the plugin number is valid, and then the search also return the true, and then this whole process will return the true. Otherwise we'll reset this position to 0 and then return false. And then I have another class is the Sudoku puzzle itself. It has few private variable here. The puzzle itself, the solution is set up, is solved, and the level. And I also create another class is Sudoku reader to read the Sudoku from a CSV file. I use the file reader and the buffer reader to read the file. So here's the summary. The Sudoku solver and checker emphasize its ability to actually you can see the demo to add in my another video. Sudoku solver and checker emphasize its ability to solve Sudoku puzzle efficiently using backtracking algorithms and to verify the correctness of solution. User-friendly graphical interface, and explain the flexibility of the application in handling puzzles, whether import from file or inputted by users. Mention the feature to display puzzle levels and provide feedback on puzzle input status. Enhance user experience. Here's the reference. Actually, Leon's textbook helped me a lot. Introduction to Java Programming. I get the knowledge of the Sudoku from chapter 8, chapter 18, and 22. Actually, the code of the Sudoku checker and reader, the code is not created by me, it's by Liang. Thank you.